What's up, class? It's Mr. Wicklehouse, and today we're talking about rewriting quadratics given the roots, solving quadratics just by taking square roots, and the vertex form of a quadratic. Alright, so let's talk about rewriting quadratics given the roots. Okay, so suppose we're given two roots for a quadratic and told to write the quadratic. So let's say that x equals 2 and 3, and they want us to write the quadratic. So what I'm going to do here is I'm going to take x minus 2, and this one is going to be x minus 3. So I take whatever these two roots are, these two x-intercepts, and I just plug them in here to x minus this and x minus that. Okay. Then all I'm going to do is distribute x squared minus 2x minus 3x plus 6. So x squared minus 2x minus 3x plus 6. And that's equal to x squared minus 5x plus 6. That's all I'm doing. Just taking the roots, putting them in here, and rewriting the quadratic. Okay? So like this one, we've got this, and this is the roots. This one's a little bit more complicated, a little bit more distribution going on, but the idea is the same. Doing x minus something, x minus something. Okay? Except what I'm minusing is 2 minus I, and over here I'm minusing 2 plus I. Okay? So I'm going to simplify inside that first. So I get x minus 2 plus I, x minus 2 minus I. Okay? Now I'm going to just start distributing. I'm going to take this one and distribute it through. So I get x squared minus 2x minus ix. Then I'm going to distribute the 2 minus 2x plus 4 plus 2i. Then I'm going to distribute the I plus ix minus 2i minus I squared. Now I'm going to go through and simplify. This is still x squared minus 2x and minus 2x minus 4x minus ix plus ix. That just goes away because that's 0. Plus 4 plus 2i minus 2i, that goes away, minus I squared. Remember, I squared is negative 1, so minus 1 is plus 1. That's x squared minus 4x plus 5. That's our answer right there. Right there and right there, that's our answers. Okay? So that's the idea with that. Moving on. Solving quadratics using square roots. This one's not too bad. Okay? So I'm going to subtract 6 from both sides. I get 9n squared equals 16. Divide both sides by 9. I get n squared equals 16 over 9. Now I take the square root of both sides. Remember, when I take the square root, I got to do plus or minus the square root. Okay, so I get n equals plus or minus this square root. A property of square roots is that I put the square root on top and the square root on the bottom. So square root of 16 over square root of 9, which is equal to n equals plus or minus square root of 16 is 4, square root of 9 is 3. Okay? Easy peasy. Here's another one. Add 7, 3b squared equals 15. Divide by 3, divide by 3. I get b squared equals 5. Square root both sides, plus or minus. I get b equals plus or minus square root of 5. That one's done. Okay, one more little quick one. Add 4, add 4. I get 2x squared equals negative 4. Divide by 2. I get x squared equals negative 2. Square root, plus or minus. I get x equals plus or minus. Remember when I have the negative under here, that's going to come out as an I. Square root of 2. And there's my solutions. So taking the square roots, pretty easy. Okay. Moving on. The vertex form of a quadratic. So here's the standard form of quadratic, which we've talked about before, I think when we were doing the quadratic formula. So ax squared plus bx plus c, and we know that the a, b, and c are important numbers when we're using the quadratic formula and so on. Well, the vertex form is a little bit different than this, and you can see right here is the vertex form of the parabola, or of the quadratic rather. So the vertex form has this multiplier out here, a, and then inside of the squared is x minus h, and then outside here is plus k. Okay. So then I have something here called the vertex. I'm sure that you guys have heard that before. So the vertex is like if you have a parabola. The vertex is like the tip of the parabola, or the top or the bottom of the parabola, however you want to think about it. And that vertex is located at whatever this h value is and whatever this k value is. So that's just the vertex. Okay. Also make note that the vertex is either at a maximum, or in other words, the highest point in the function, or it's at the minimum, the lowest point of the function. Okay. So this case right here, this would be a minimum. Okay. There's also something called the axis of symmetry. And the axis of symmetry is a line that cuts the parabola into two equal parts. So if you remember from geometry, symmetry, a line of symmetry is just kind of like, if I folded that over in half, then it would be equal on both sides. And that's the axis of symmetry. And it goes directly through the vertex of the parabola. So if I was looking for the equation for the line of symmetry, or the axis of symmetry, this is a vertical line, so I know that it's going to be x equals something, because vertical lines are always x equals, because it goes through the x-axis. And then I just take the h value of the vertex, and that's my equation for my axis of symmetry. Okay, so let's look at a little example. So this is matching the vertex form with the graph of our parabolas. Okay, so they give us this equation, y equals negative quantity x minus 2 squared plus 5. Well, I can see that my h here is 2, and my k here is 5. So that's the value of my vertex. That's where my vertex is. This is at 2, 5. 2, 5. 2 on the x, 5 on the y. Okay. Also note that this here, it's the highest point on this graph, so this is a maximum. Okay. If it was flipped the other way, it would be a minimum. Also notice that here is our axis of symmetry. It notice that it cuts the parabola in half so that if I folded the parabola up, it would be equal on both sides. And that axis of symmetry is the x because it's a vertical line, and it's the value of h. So x equals 2. The axis of symmetry happens at x equals 2. Okay? That's all for today, guys. I'll talk to you later.